Hi everybody, Patrick here from EngineeringShock.com, electroniclessons.com, and paintballprops.com. Today we're going to put together an RFID123 RFID reader module based on our most recent Kickstarter campaign. It will also be listed at EngineeringShock.com very soon. This video will serve simply as an assembly video. We'll solder this together piece by piece, and my next video will be a full-on video manual. So this video will just put it together. In any case, let's talk about the components. 6 10k ohm resistors, 4 470 ohm resistors, 1 custom PCB, 1 18-pin dip socket, 1 18-pin programmed microcontroller, a 5-volt buzzer, 2 single-pole double-throw SPDT relays, 1 5-volt regulator, 7805, 2 3-pin terminal blocks, 1 2-pin terminal block, a 0.1 microfarad ceramic capacitor, a green LED, 6 red LEDs, a DC power jack, 2 2N2222 NPN transistors, 3 100 microfarad electrolytic capacitors, 2 diodes, 1N4001, 1 9-pin header, 7 2-pin headers, and 6 jumpers. Oh, my bad. 1 momentary push button, and lastly, an RFID reader with antenna. So first of all, what we're going to do is we're going to solder in our resistors, and after that we're going to solder in our capacitors and LEDs. First, let's start with our 470 ohm resistors. They're the easiest. They go in the R4 slot, R4, R1, R2, and R3. Now, they're labeled 470R for 470 ohms. So the resistors have no polarity, so solder in your 470 ohm resistors in those 4 slots. Your 10k ohm resistors go in these slots: R9, R7, R8, R10, and R6. So that's 6. They're all labeled 10k, and they've also got the resistor numbers beside them. So the nice thing is the 470 ohm resistors are on the top, and the 10k ohm resistors are on the bottom. Here, 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 and lastly here. So solder those into place. Again, resistors have no polarity. Just make sure that you put the right values in the right spots. Make sure you have nice clean solder joints and that you trim off the excess leads once you're done. Next, we'll talk about our capacitors and our LEDs. Let's start with the LEDs. So again, we've got 6 red LEDs, 1 green LED. What you'll notice about all the LEDs is that there's a long pin and a short pin. Long pin, short pin. And so that means that there is a positive and a negative. Positive is long pin, short pin is negative, or rather, positive is anode, short pin is cathode. Anyhow, all you have to remember is long pin positive, short pin negative. So all the LEDs go in these slots. Now the LEDs are labeled 1, 2, 3, 4, 5, 6, and in. In is indicator. So what we're going to do is we're going to place our single 3mm LED first. Now before we do that, we need to know which side is positive and which side is negative. In every single case, the positive should be placed in the top hole, and the short pin, the negative, should be placed in the bottom hole. So I'm going to take, as an example, my green LED. I'm going to take the long pin, place it in the indicator LED slot, long pin on the top, short pin on the bottom. And once I do that, I'm going to make sure that it's flush to the board, bend 1 pin back, go to the back of the board, and solder it into place. Once I'm done that, I'm going to take my red LEDs and place the long pin on the top of any of the slots, short pin in the bottom, feed it through, and again, make sure it's flush in the back, pull one side up, solder it into place. You can hold that down to ensure that it's flush to the board when you solder it into place. In any case, solder those all in, and we'll do our 4 capacitors. Easy step. Let's start with the easier of the 2 components, the 0.1 microfarad ceramic capacitor. Notice that the leads are the same length. There's no polarity on this capacitor. All you have to do is solder it into the C1 slot, labeled C1 0.1U. Now, the electrolytic capacitors go in the C2 slot, C3 slot, and C4 slot. Now, what you'll notice about the electrolytics is the fact that they've got a long lead and a short lead. Like the LEDs, there's a positive and a negative. For the case of C2, there's a hole in the top and a hole in the bottom. Place your long lead, your positive, in the top hole, and your short lead, your negative, in the bottom. Now, you'll notice on the top hole, just to the right, there's a little tiny plus sign. That'll help you just in case you forget. C3, there's a pin on a hole on the left and a hole on the right. Above the hole on the left, there's a little plus sign. You want to place your long pin in the left, short pin on the right. And in the case of C4, you want to place your long pin on the top. There's a little plus sign just to the right of it, and your short pin on the bottom. Now don't mix these up. Make sure that you place them in the right polarity the first time around, or else when you power it up, you could blow them up and damage your board. So solder those into place, take care with them, and next we're going to do our headers. Let's talk about the 2-pin headers. They're very easy. They go in this slot, R2 as in relay 2, R1 as in relay 1. The 2 lock header positions, set, PRG, and lastly LED enable, LED_EN. Now what you want to do typically is, this is what I like to do. I like to take a 2-pin header, pop into place, and from the back of the board I hold it down with my fingernail. I turn the board around and I solder 1 pin. From there I check on the back to make sure that it is still flush, and then I solder the other pin. And that's what you're going to want to do with all of them. You can do it your own way. That's the way I find it is the easiest to not get burned by the soldering iron. Now for the single 9-pin header, you simply pop it in up here, hold it down with your thumb or with your fingernail, solder 1 pin, solder the left pin and the right pin. Just make sure it's straight, then solder the rest of the pins. Now it's easy. It's not easy to, but if you don't have a nice fine soldering iron, you might have trouble soldering that without shorting. I don't have any trouble, but I've got a decent soldering iron, and I've got years and years of soldering experience. So if you don't, just make sure that after you've soldered all those in, that you take a magnifying glass to ensure that there's no shorts between the pins. In any case, next we will do the 18-pin socket, the transistors, and the terminal blocks. The DC jack fits in this slot right here. It only fits in one way. There are 3 pins. Now when you place it down on the board, make sure that it's flat on the board. And from the bottom, what you want to do is get some solder on the bottom of your soldering iron and essentially just try to connect 1 pin to 1 pad. Once you have it connected and you're certain that it's flush to the board, then solder the rest of the pins. Now don't spend too much time soldering on each pin or else you'll melt the jack. Just try to make sure that there's decent connectivity between the 3 pins and the jack. It literally fits right on like that on the top of the board. The 3 terminal blocks are extremely easy. There's a 2-pin and 2 3-pins. You want to make sure that in every case that you don't solder them in backwards, because there's one side with terminals and one side without. So if you soldered the side without facing inside of the board, then you wouldn't be able to make any wire connections later on. So this is an additional power supply terminal block. So when you're placing it in the slot, make sure that the terminals are facing outwards, like so. In the case of the 2 3-pin terminal blocks, again, terminals on one side, no terminals on the other. Make sure that you place the terminal side facing outwards. And what I suggest doing there is to make sure that they're nice and straight. Hold it down when it's nice and straight, because they can move either way a little bit. Make sure it's nice and straight on the board. Hold it down with your finger, and from the other side, solder the middle pin or the right pin in both cases, or the middle pin and the left pin. And so you'll be able to see if it's flush. And then you'll have a little bit of adjustment after you soldered it, but really it doesn't make too much of a difference. Now the terminal blocks have nice big pads on them, so make sure you have a nice healthy amount of solder on each pin. You won't easily short pins to each other. You'd have to really be gobbing it on. But a very, very easy step. Solder those into place, and then next we'll do our transistors and our socket. From here it might be a little bit difficult to see, but on the 18-pin dip socket there's a little notch on the left-hand side. On the footprint, pick 18F, where the socket goes, there's a little notch on the left-hand side. So from this perspective, make sure that you place the socket in with the notch facing the left-hand side. And once you have it in place, hold it down with one finger. It's a little bit difficult to get it to sit in place from this position, so I'm just going to stop. Once you have it in place, solder it in, and make sure that it's flush to the board. You're always holding it down with one finger. And double check after you've soldered a couple pins. Make sure there's no shorts. And again, very, very important that you have the notch facing left, because that's going to act as an indicator. That's going to tell you which way to set your chip. Now, if you set your chip backwards, you're going to destroy it. So be very careful. Now, the button goes in the cell slot. Now, it's very, very simple, and it only fits in one way. So line up the pins to the holes and pop it down. It should pop into place. Once it's popped into place, make sure it's flush to the board. You shouldn't need to hold it down once it's popped in, because it'll essentially stay. It will basically grab the board. Solder all 4 pins. You shouldn't have too much trouble. There's the 4 holes are far enough away from each other that you shouldn't be able to short it. Now, lastly, for this step anyway, the transistors, on the transistors there's a flat side and there's a curved side. So you can see this one is teetering on its curved side, whereas this one has the curved side facing up. Now the front side also has a writing on it. It'll tell you 2N2222. Now they go in the T1 slot and the T2 slot. Now as you'll notice on the footprint, there's a flat side and a curved side. Flat side on the back, curved side facing the front. So when you pop it into place, you want to make sure that you have the flat side of the transistor facing up and your curved side facing the bottom of the board. If you reverse those, your relays won't work if you have your relays enabled. So again, from a bird's eye view, flat side facing the top of the board, curved side facing the bottom of the board. Solder those into place, and next we will place our IC into our socket. We'll do our relays and we'll do our buzzer. Our board is starting to take shape. Now an easy step. The programmed PIC microcontroller. There's a notch on the left. There's a notch on the left of the socket. Line up the bottom pins first, then the top pins. Add a little bit of pressure. Make sure that if you know that they're sitting properly before you push down and lock it into place. If you're not careful, you can damage the pins. Okay, so the buzzer, again, long pin, short pin. On the top of the buzzer there's also a positive indicator, and right underneath is the long pin. On the buzzer footprint there's a plus sign and a minus sign. So long pin on the left, short pin on the right. Flush to the board, solder it into place. The two relays, very easy, although they require quite a bit of solder. 3 pins on one side, 2 on the other. It only fits in one way. Make sure it's flush to the board, turn the board around, holding it down, and solder 1 pin. And from there it should sit into place and you can solder the rest of the pins. So do all that soldering, make sure all your leads are cut, because apparently I forgot to cut off my transistor leads. Very important. I'll be cutting those off after this step. So once you've got all of those components placed, we are then going to solder in our RFID antenna reader and our 7805 5V regulator, and then that'll be the end of the video. The RFID reader has 2 pins on one side and 5 on the other. The footprint has 2 pins on one side and 5 on the other. So what you want to do is carefully connect the reader to the board. Now if you place it straight down onto the board, you'll just have to bear with me for 1 second here. It looks from the top that it fits nicely, and it does fit nicely, but you want to make sure that it's not tilted either way. You want to make sure that it's level. So make sure that it's level before you solder it. And what I suggest doing is soldering 1 pin, checking to make sure it's still level, solder another pin on the other side of the reader board, making sure it's still level, and then you can solder the rest of the pins. Now I suggest cutting off the excess leads on the pins. You want to make absolutely certain that there are absolutely no shorts. If there are shorts, you're going to have a bad day. So solder your reader in, and once you've done that, take the last component, your 7805, and solder it here with the back of the 7805, the gray part, facing the reader, and the black side facing the DC power jack. If you reverse this, like this, then it won't do its job and you'll fry the board. You want to make sure that the front side with writing on it is facing the DC power jack. So solder that all into place, and we'll do a quick test just by powering it up. Take a 2-pin header jumper and short the LED_EN pin header, and that will enable our indicator LEDs. And place 1 more on the PRG pins, and then power it up. You've got your RFID card in hand. We're going to program in all of the RFID slots using 1 card. You can use up to 6. So basically, once I'm done programming, this 1 card will activate all of the outputs. So we're just testing the hardware here. Does the RFID reader work? Yes, the RFID reader works. LED 1 works, and the indicator LED works. So I'm going to do it again. LED 2 works. 3 works. 4 works, and 5 works. And sorry, 6 works. So what we've tested all the LEDs, we've tested that power is going to the processor, we've tested the RFID reader and antenna, it all works. So we'll unplug it. Take 2 more pin headers and short the lock headers, and that will lock that code into EEPROM memory. Next we're going to remove the PRG header and connect it to the set header. You don't have to do that. You can leave the set empty if you'd like. We're going to connect another header to R1 to enable relay 1, and we're going to take one last one and connect to the R2 header. Now this will test, we're going to test the functionality, we're going to test the EEPROM memory here, we're going to test the buzzer, and we're going to test the 2 relays. So we should hear clicks if the relays work when we use the RFID card that's been programmed. So the relays work. If you want to double check, remove one of the headers, one of the relay headers. Do we still hear that click? Yes, we do. Take the remaining header and plug it in the opposite relay slot. These 2 headers activate the relays. And we still hear the click, so yes, relays 1 and 2 work, all the LEDs work, the EEPROM memory works because we unplugged it and this card has all the save data, and lastly the reader works. Now, second lastly, we're going to take the other RFID card that we didn't program in. We're gonna. So our buzzer works. This RFID card is not associated with the program. This one will activate all outputs. So we've tested all of the peripherals except for the button. So remove power and remove the set header. And what we're going to do here is we're going to activate all the outputs. And we're in latching mode now, so all the outputs will stay on. I'm going to press the sell button and it should clear all the outputs. Yep. So everything works. We've tested all the peripherals, and yeah. So happy day. Hopefully this video helped you put yours together. I'm sorry if it was a little bit jumbled. I know that when I'm putting these videos together, sometimes I can jumble my words a little bit. I hope you're able to be patient with me through that. So that's your RFID123. The video manual will be uploaded very soon, and I'll link it below when it's done. Thanks for watching, guys.